4. Okay, so one time that you could use linear inequalities in real life is this thing called linear programming. I don't know why it's called linear programming.
I don't know why it's called linear programming either.
There's not a real connection to
well,
like
it's
what
made
you're
up
doing.
of lines, I guess.
It is made up of lines, but it has to do with finding maximum and minimum values for a function that you have that then is based on certain constraints. So in case we're unfamiliar with what the word constraint means,
it's a limiting factor.
Yeah, so when your parents say you can, you have 2 gigs of data for your cell phone plan in a month and that's it, that's a constraint.
Right.
You're supposed to be less than or equal to that 2
and if
gigs.
you go over that, you get the wrath of mom. Right,
exactly. So that's what constraints mean. So what they're going to do, this is a basic problem already set up for us, and then we'll look at a word problem.
It's beautiful.
In a
Beautifulness.
sec. It asks us to find the minimum and maximum, if they exist, of the objective function f subject to the following constraints. So
basically, all that gibberish means solve it out.
Yeah, absolutely.
Honestly.
Yeah. The objective function you do not graph with the rest of it.
No, you don't graph.
You just take the rest of these inequalities and you graph them. So x is greater than or equal to 0 and y is greater than or equal to 0. Just means we're going to be in the first quadrant. Okay, so that's why my graph is only first quadrant here. And most, if not all of them, should have that because we're talking about real world problems where x and y would not be negative numbers. So we need to graph.
Does my eye look okay? I feel like something's in there.
I see an eyeball.
All right.
Maybe there's
maybe it's my
wonky
finger.
eyelash thing going on.
All right.
Okay. So I'm going to graph these using intercepts because if I cover up the y in this first one, then I get x equals 90. So at 90, which I'm going to make these go by 10. So at 90, that's going to be my x-intercept. And then same thing, if I cover up x and solve for y, I get y is 90. So those are my intercepts. And then
so your line just crosses through both of those.
Totally, just crosses through.
It just crosses through. It's pretty important to try and draw straight lines on all of this BT dubs.
It is pretty helpful. You don't want some crazy lines that are going to end up making you look at something wrong.
Right.
Now this second one, I can't really do with intercepts because they're both 0 if you cover up since it equals 0. I mean that's kind of awkward. So just actually solve it out. So we would have negative y is greater than or equal to negative 3x because we subtract the 3x over. When we divide by negative 1, that gives us y is less
Remember,
than
anytime
or
you
equal
multiply
to,
or divide by a negative, just multiply or divide, your inequality changes sides.
Absolutely. So that's 0, 0, and then we're going up 3 right 1. And as long as our scale is the same on x and y, we can still
Doesn't matter
how,
you just go up 3
like this situation.
Into the right 1.
Okay, and then we're going to draw our line. And also typically with these, we are going to have equal to's on them and not just
usually with linear programming, yes.
Okay, so now we want to shade where these are overlapping. So the first one, x and y are less than or equal to 90. If you want to think about solving that for y, so we subtract x over, we do have less than, which is below.
You can always test a point, 0, 0 or whatever.
You could. So that's this way on this line. Oh,
you're still lines.
Okay, and then for the pink line, we are also less than, so that's this way. And so our answer solution-y area here is this part right here where we graphed, where we shaded pink and
purple.
So this orange. Now here's what's neat about this is that all of these points inside of this triangle are solutions to this problem.
To every question that we've been asked so far.
Right. All of these points, like any point you pick in there, you can plug into these inequalities and get true statements.
Right.
What we want is to now figure out which of those points will give us the maximum value when plugged into this function.
To that objective function.
And the minimum value. Well, it just so happens there's like this theorem-y thing whenever you do this, that if there are a max or a min, they have to happen at the corners of this region.
Right.
And by corners, look, this is a triangle, so here's a corner, here's a corner, here's a corner.
Yep.
So let's name those corners. This is 0, 0.
Yeah, and it's a good idea to name them by the actual points that they occupy.
Yeah, not like Leon.
Yeah.
Like Point Leon? No, that's not what
That
we're
one's
talking
Point
about.
James. Over there is Point Chucky.
So this one's 90, 0. Now this one up here is not on a little like intersection-y point, and most of them won't be. So we actually need to sit here real quick and solve this to see where these two lines are intersecting. And we could either use substitution, because we solved this for y,
Right.
or elimination would work out real well here. We'd have 4x, and since we're seeing where they're equal, so now this is an equal sign. So 4x, the y's cancel, equals 90, divide by 4 on both sides.
Let me just see if that gives us a pretty
It gives us 45 over 2, which is not...
22 and a half.
Okay, so...
Probably want to know the fraction on this part may not help as much.
It depends. Like
Just
if
depends.
it's it's kind of whatever on that. So now we're going to, let's see. Oh, that's x. So plug that in and find y. Well, here's a y situation. So y equals 3 times 22.5. What does that give us?
Times 3. 67.5.
67.5. So that's this point up here is 22.5 comma 67.5. So we're going to take these three things and plug them in right here to our objective function, and then we'll say what our maxes and mins are. So
Right.
22.5.
$967.5.
967.5. All right, so now I'm plugging in 0, 0. Doesn't
0.
yeah.
I got that one
You got
without the
that one.
calculator.
I bet you
I'm
could
on
do this one too if you wanted to.
10 times 90 plus 11 times 0. 900.
900. Okay.
How'd you write it out already?
Just magic. Just
That
a little bit of
it's all that
magic.
master's work that you've been doing in math.
Right. So our maximum for the objective function is 967.5, and it occurs at the point 22.5, comma 67.5. That's how we write out that answer. The max is this amount at this point. The min is 0 at
0,
0, 0. And I'm getting that because which of these numbers is the smallest?
0.
Which of them is the biggest? It's
nine-
close. It's a little close.
Let's go with 967.5 on
Right.
that one.
So that's how I picked which point was the max and the min. Now, in order to, because it says if possible, right, or if they exist.
Right.
A max wouldn't exist if your shading just keeps going up
Going
and right.
up to the right, yeah.
Yeah.
There's no
There's no point out here where it
There's
like,
no end to the
stops.
shading. Yeah.
Because what's happening here, since we have a triangle, is there is a biggest number that we can plug
Right,
in.
right.
And get, and there is a littlest number that we can plug in and get.
Yes.
So both of them exist. And that's it. That's
Okay.
for that.
There you go.